Hello everyone, I am Shivam Verma, Assistant Professor, School of Pharmacy, BBD University. Today I would like to talk about the topic size reduction. Okay, so in this topic we will cover size reduction, objectives of size reduction, mechanism of size reduction, factors affecting size reduction, then the equipment which are used for size reduction, that are hammer mill, ball mill, edge runner mill, end runner mill, and fluid energy mill. Okay, so starting with introduction of size reduction. Okay, so size reduction is the process of reducing large solid mass into a small unit masses, coarse particle or fine particle. So as you can see from the diagram that these are the large solid masses. See, so these are reduced, the size or reduced into the small fine particles. These are small fine particles. So large unit masses are reduced to the small or fine particles by the application of the size reduction. So size reduction is simply unit operation uh, of the reduction of the material into small particles or coarse particles or to a powder. It is basically employed in the pharmaceutical industry. Okay, and the size reduction process is also known as comminution or grinding. Okay, so moving to the objective of the size reduction. So first objective is size reduction leads to increase in surface area. So if we reduce the size of any particle, it will increase the surface area of that particle. Okay, so if the surface area will increase, the solubility of that particle will also increase. Okay, solubility of that particle will also increase. If we take the example of any drug, so if the surface area of that drug by reducing the size increase, then the solubility of that drug will increase. Okay, then if solubility increase, its dissolution will also increase. Its dissolution will also increase. So if dissolution increase, the absorption of that drug will increase. Okay, so next point is this, the to increase the therapeutic effectiveness of certain drug by reducing the particle size. So as you can see, if the particle size increase, the particle size reduce, the size reduction of the particle size, then their surface area will increase, solubility will increase, disso will increase, and absorption will increase. So the therapeutic effectiveness of that drug will be increased. Okay, next is size reduction produces the particle in narrow size range. Mixing of powder with narrow size range is easier and uniform. So if there is a particle with uniform particle size. Okay, small and uniform particle size, so it is easier to mix these particles as compared to if there are large particle, small particle, large particle. So these particles cannot be mixed easily, and the mixing is not also uniform in this type of particles. But if you are having the uniform particle size, narrow size range, so mixing of that particle will be easier. Okay, the last objective is the pharmaceutical suspension require finer particle size. It reduces the rate of sedimentation. So if you are having the suspension with fine particle size, the rate of settlement of that particle will be less as compared to large particle. So the fine particle size is preferred in suspension, so that the sedimentation rate is low. Okay, next is mechanism of size reduction. So in mechanism there are four mechanism of size reduction. First is cutting. Okay, in cutting the material is cut by the means of sharp blade. So you can see that this is a blade, and the material is placed in between the surface and the blade, and it is cutting down. So the size is reducing by the help of the blade, or you can use the knife for the size reduction. Okay, so in cutting, material is cut by the means of sharp blade. Okay, Next is compression. So in this, the material is crushed by the application of pressure. Okay. So you can see that these are two surface, and the material is placed in between them. So thus pressure is applied from both the surface, and the material size is reduced by the application of pressure. It is compression. Okay. Next is impact. So in impact, the material is hit by the object moving at high speed, or material strikes a stationary surface. Okay, so if the material hit by moving object or a material strike by any surface, the material will shatter into the smaller pieces and the size of the particle will be reduced. Okay. Next, attrition. So in attrition, material is subjected to pressure but surface moving relative to each other. It resembling to compression, but in this you can see that the surface is moving relative to each other. So the resulting shear force will break the particle, and the reduction of the particle size will be takes place in attrition. Okay. It is the mechanism of size reduction. The four mechanism: cutting, compression, impact, and attrition. Next, moving to the factor affecting the size reduction. So in this, the first factor is hardness. So you know that it is difficult to break the hard material, but if the material is hard but brittle, so there is no such problem. As you can take the example of chalk. So chalk is hard, but we can break it easily because it is brittle, it is easily breakable. So it will not cause problem with such material that are hard but brittle. But some material are hard and not brittle also, so there is such problem with that type of material. Okay. Next is toughness. Okay. So toughness is the important factor, as the soft but tough material present more problem in size reduction than hard but brittle substance. Okay. So as you can take example, it is easy to break the blackboard chalk, but it is difficult to break a rubber because rubber is soft but tough. So we are not able to break or reduce the size of rubber. So in that, we treat such material with liquefied gas, such as liquid nitrogen. So these material are cooled at lower temperature than minus 100 degrees Celsius to minus 150 degrees Celsius. When these material become brittle, like rubber become brittle at this temperature and breaks. So after that, we reduce the size of that type of material. Then the factor is stickiness. Okay. So it is a property which may cause difficulty in size reduction. In this, the material may adhere to the grinding surface, or the meshes of the screen may get chalk when they become soft. Okay. So these problem occur with gummy or resinous substance, cause such problems because of the generation of the heat during the size reduction. So for this, sometimes we add some inert substance such as kaolin, sulfur, to reduce the stickiness of the such kind of substance. Next is softening temperature. So during the size reduction process, heat is generated, which may cause some substance to soften. Thus, the temperature at which it is occur, it is important. Okay. So waxy substance such as stearic acid or drug containing oil fat may get affected. So overcome these problem, cooling the mill either by water jacket or by passing steam of cold air through the equipment, or by liquid nitrogen, can overcome these problems. Next property is abrasiveness. So abrasiveness is a property of hard material, particularly that are those of mineral origin. So it may limit the type of machinery. So sometimes grinding abrasive material, the final product become contaminated with the ore. So more than 0.1% of material ore from the grinding mill can contaminate uh, the product. Okay. So next is the physiological effect. So in this, some substances are very potent, and a small amount of fine generated may affect the operator's health, which operators means which operating the size reduction machineries. So avoid these problems. The mill which was used should be enclosed, and exhaust system should be provided, and if it is possible, wet grinding performed to eliminate these problems. Next is material structure. So material used in pharmaceuticals are wide variety, which some are being homogeneous but some show special structure. So like take example of have line of weakness which may splits into flakes, but the herbal drugs having the cellular structure that leads to fibrous particles. So resulting product at particularly operating condition may vary in their size in the herbal drugs and the mineral substances. Next is moisture content. So the moisture content present in the material affect the size reduction. That wet mass will hamper the milling process. So usually less than 5% of moisture suitable if substance is to be grounded dry, or more than 50% if the it is subjected to wet grinding. Okay. So these are the factor which affect the size reduction. So for uh, for today's lecture we will talk uh, here only, and in next lecture we will cover the equipment that are used for the size reduction. So thank you.